Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Chili Sums by Sudoku. And here are the rules. We have normal Sudoku rules applied. That is, each row, column, and 3 by 3 region has to contain the digits from 1 through 9 once each. We have yin-yang shading, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected, and no 2 by 2 area is fully shaded or fully unshaded. So here's an example of a valid yin-yang shading, where you can go from any cell in the shaded region to any other cell in the shaded region just by going through edges, all while staying within the region, which is what it means for a region to be orthogonally connected, or all cells of a region to be orthogonally connected. Same with the unshaded region. You can go from this cell to any other cell in the unshaded region just by going through edges, all while staying within the region. What you could not have, though, so this is a valid yin-yang shading. An invalid yin-yang shading would be something like this, because for these cells can no longer connect to any of these cells in the unshaded region. They either have to go through a corner or go through an edge and exit the region, which is not allowed for yin-yang shading. This is also not a valid yin-yang shading because this 2 by 2 area is fully shaded, and that's not allowed, again, for yin-yang shading. And those are examples of how yin-yang shading works. Now, the value of a cell that contains a digit x equals x if the cell is unshaded and negative x if the cell is shaded. So that, for example, if this were, say, a 6 here, the value of this cell would be -6. Obviously, if you had a 6 here, then the value of this cell would be 6 because it's unshaded. So shaded cells are essentially negative, and unshaded cells are positive. We have thermometers, where values along a thermometer must strictly increase from the bulb end. So you cannot have, so values on the thermometer must increase. It does not mean digits. So if in this example this doesn't work because these are both positive and these are all negative values. And you have to be increasing from the bulb to the tip. From going from a positive to a negative value, obviously that's not going to work. This actually could work. So you could have something along the lines of, say, 9, 8, 7, 2, and then 1. And this would be valid because -9 increases to -8, increases to -7, to -2, to 1. It always increases from the bulb to the tip. So that's how thermometers worked. We also have signed x-sums, where if the first value seen from a clue outside the grid is positive, the respective clue indicates the sum of the first x values in the respective row or column. If the first value x is seen from an outside club is negative, the respective clue indicates the subtraction of the first x values in the respective row or column. Okay. Of the first absolute value x values. It's realistically, it's the first. Interesting. I'm not sure how I would phrase that. I think I get it, though. So basically, you have a digit in the first cell. If it's a shaded cell, then if it's unshaded, then it's basically the value the clue is the sum of the first x values in the respective row or column. And if the first value is, if the first cell is shaded, you still have the digit x in there. And so the first x cells, this clue indicates the essentially subtracting the first x values in the respective row or column. Interesting. Huh. So how does that work? So obviously, sum is easy, right? If you have a negative value, that essentially subtracts that value. If you have a positive value, just adds that value. And you take the first however many x digits, which x cells, where x is the first digit seen. And it's the same for negative, right? This would be, so, well, except negative is the subtraction of the first x values, x being the... Yeah, I think I would prefer it that if the first cell is shaded, right? Anyways, but it's fine doing it this way. So if the first value x is negative, the respective clue indicates the subtraction of the first x values where x is the digit, or the digit that creates the value in the respective row or column. So the thing is, that's interesting. So if you have a 5 here, so say this was a negative 5 in value, then this subtraction of that, so you would subtract a negative 5 here, which would add essentially 5. You would subtract this digit, which would give you a negative value here. This would be subtracting, again, a negative value, which would be adding to that. And you'd have a negative here. And then, so... I guess we could make it 8. And then so you subtract out all the negative values here, which would give you a positive value for that, and that would be a sum of essentially those digits. And then you would subtract out the negative values here to get to negative 10. So that's how these signed x sums work. Interesting. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Anytime you have 4 digits that are in a 2x2 area that are in a thermometer, one of them, you know at least one of them must be positive. And so therefore, this is always going to be positive. You also know one of them is always going to be negative. So you know this is always going to be negative, right? So that's for any 2x2 area that has a full thermometer in it. So full 2x2 area, this has to be positive and this must be negative, right? Because the smallest one has to be near the bulb, and the largest one has to be at the tip. 2x2 area here, this is always negative, this must be positive. So since this is positive, this must be positive here. So we have a guaranteed change on the edge of the grid here in color. Same with this 2x2 area. This has to be positive and this must be negative. 2x2 area, this has to be positive, this must be negative. 2x2 area, so this is negative, this must be negative. These have to be negative here. This must be negative here because it's less than that value. This must be negative here, so it has to be that value. So we have a change of shading here, guaranteed. We have a change of shading in row 1, guaranteed. So that means in yin-yang shading, you can only have either 0 changes of shading or 2 changes of shading in each on the edge of the grid. And the reason why is, say we didn't have something like that. Say we had green here, and then this is blue again. How do you orthogonally connect the green without breaking apart the blues into 2 separate regions? You can't. Same with the blues. How do you orthogonally connect the blues without breaking up the green region? They can't. So therefore, this is always going to block. If you have more than 2 changes of shadings in... sorry, you can't have more than 2 changes of shading. You can only have 0 or 2, I should say, changes of shading on the edge of a grid for yin-yang shading. So this must be green here. So that means this is green this way. Also, another thing about... So these are sort of... well, I mean, they're things you can deduce immediately. But the thing is... this cannot be negative negative. If these are negative negative, this does not orthogonally connect to the rest of the greens. So this has to be at least positive here, which means the rest of these are positive, which means this must be positive since you have to orthogonally connect to the rest of the unshaded cells. So the main 2 deductions you have for yin-yang shading is you either have 0 or 2 changes of shading on the edge of the grid. Another one is if you have 2 cells that on a diagonal are the same shading. On the opposite diagonal, you cannot have colors of the same shade. So for example, if you had blue blue here, this obviously can't be blue blue because a 2x2, you'd have a 2x2 area that's all blue. If you try to make this green green though, how do you orthogonally connect the greens together without breaking apart the blue cells into multiple regions? And the answer is you can't. Same thing with trying to orthogonally connect the blues without breaking apart the greens. You can't do that either. So if you have a diagonal of one color that's the same shade, for the other diagonal, it must be one of the other color and one of the same color. So for this being 2 blues here, this is green. This cannot be green here because again, this would be, can't have this as the same shading. So therefore this must be blue. And we have another similar one here. This is both green. If this were blue here, this wouldn't work. So this must be green here. We also have 2x2 areas that are all green or all blue. So this can't be green, that's blue. This can't be blue, that's green. This can't be blue because we have a 2x2, so that's green. Same with that, so that's green. So the rest of this must be green to be increasing from that cell. Okay. So now we know the sum of... So this is... Let's go... Well, we don't know. This is the longest thermo. So this could be -9, -8, -7, -6, up to 1, 2, 3, and 4. So this has to be 4 through 9 here. This must be less than that, so this is 8, 7, 6. So 1 through 6 here, 2 through 7 there, 3 through 8 there. This could be -1 through 6. This is less than that, so -2, -3. And this must be -4 at the least. Here we have -9, -8, -7. And we don't know what this is. This could be -9, -8. This is at least 1, at least 2, at least 3. So 3 through 9. This is less than that. 2 through 8. 1 through 7. This is 1 through 8 and 2 through 9 there. We don't know what this is. So this could be, this is any digits 1 through 9. This is also any digits 1 through 9. This has to be 1 through 7. This is less than that, so it's at least -2. This is at least -3. Okay. So how does this work? Can we have 8 digits? The sum of 8 digits would be 8 and 9, 17. But the next 6 digits would be 1 through 6 at minimum, negative. So that's -21. So that's not possible. So this cannot be 8, which means this can't be 7. Can we have 7? Possibly. Yeah, you would have 7, 9. Then this would have to be 1 through 6 here. That is possible. Sorry, 1 through 5 here. So 7 and 9 is 16 minus 1 through 5. That is possible. Okay. This has to be... So this is negative... This is 1 also. So we take the subtractions of that. So these are all positive values for the sum, and these are negative values. So again, this has to be 9, 8, 7, 6, 5. Or not 5. This is 1. So this could be 1 through 9. This has to be less than the positive number, which could be -1 through 6. This is less than that, -2, -3, and -4. Okay. So if this were 7, that would force us to be -8, -9. We would subtract that, so that would be 24. But the problem is that this would be at most in value 1 through 6, which is 21. 24, which would be, you would subtract that version. So it's -20, 0 minus -24, which would make that 24 here. And then you subtract out the positive values, which would have to be 1 through 6, which would be 21. So that would equal 3. So we cannot have a 7 here, which means this can't be 6. You can't have 2. That's just too few. If you have 2 here, you only have negative values. And that would be 5. That would be too big. 3 is the same thing. These would be negative values. Subtracting out the negative values would give you a sum of a difference, whatever, of 9. So this can't be 2 or 3. So it's -4, 5, or 6. This must be smaller than that, so it's -5. This must be smaller than that. So -4, 5, and 6 is 15. 15 minus a singleton digit is not going to work to add up to get to 1. So this can't be -4. So this has to be -5 or -6. This has to be at least 1. This is at least 2, at least 3. So 3 through 9 there. 2 through 8 there. 1 through 7 here. So what happens if we do have 8 and 9? I don't think that's going to work. We have 8 and 9 there. That becomes 7, which forces that to be 6. That's 5. Oh, that does actually work. Never mind. So if we have 5, This adds up to at most 17, which would mean that's 6, 7, and so that would force 8, 9 there. So that does work. What happens if we have 6? That means these would be 1 greater than these summed up. That seems okay. This has to be at least 1. We have at least 2 here, at least 3. 2, 3, 4, 5, 6, 7. 1 through 7 here. Okay. We have a 2x2 area that's all green here, so this must be blue. 2x2 area that's all blue, so this can't be blue, it's green. This can't be 7, because that would force this to be 8 and 9. That would eliminate all possibilities for that cell there. So that means this can't be 6. Can we actually have 3 here? 3 and 2 gives you 5 at most. Again, this is at minimum 5, 6, and 7. 5, 6, and 7 is 18 minus 5. So that doesn't work. And if we tried 6 here, 6, 7, and 8 adds up to 21. So, okay, what are the possibilities with this? So 5 means 5, 6, 7. It has to be 5, 6, 7, 8, 9 here, if that's the case. So if this is 5, this adds up to at least 18. It's the negative version. You're subtracting out a negative, so that essentially adds those digits. And 18 minus 17 gives you 1. So if this is 5, it's 5, 6, 7. This is 8, 9. If this is 6, this is at minimum 6, 7, and 8, 21. So these 3 must add up to at least 20 in that instance. 6 without 6, 7, or 8 available. Is that even possible? So 6, 7, 8 is 21. 21 minus 20 would give you 1. But the problem is you have 3 other digits here, and so 21 plus 20 gives you 41, which means the remaining digits in this row would have to add up to 45 minus 41, which is 4. So that's not possible. So this has to be -5, -6, and -7, which gives us 8 and 9 there. So that means this cannot be 5, 6, or 7 in the rest of this box. 7 cannot be in the rest of this column. This digit is greater than that, so this cannot be 6. Also, we have a 6 there. Remaining digits in this row, then. So this is 5, 6, 7, which is 18 minus 17, which gives us 1. Actually, sorry. You subtract -5, -6, and -7, which gives us 18 as a sum. And you subtract 8 and 9 from that, which gives us 1. That means the remaining digits in this row are 1 through 4. And this has to be not 5 through 9, so it's 3 or 4. This is less than that. So then this is 2 or 3. And we have 1, 2, 3, 4 here as possibilities, and 1, 2, 3, 4. This is less than that, so this has to be at most 1 or 2. Well, we have a 1, 2, 3, 4 quadruplet in this box, which eliminates 1, 2, 3, 4 in the rest of the box. So these are definitely 5 through 9. Since these are all 5 through 9, it's not going to be less than 1 or 2. So these have to be negative values. So this is going to be less than this, which is less than this. So then this has to be -5, 6, 7. This is -6, 7, or 8. And this is -7, 8, or 9 there. So this is 1 or 2. That means 1 or 2 has to be whatever digit's missing in this box 3 has to be the same as that. So this is 1 or 2. Okay. They have 2 negatives on a diagonal here, so this must be blue also. We have 2 by 2, that's all green, so that must be blue. 2 by 2, it's all blue, so this must be green. Diagonal, that's green, so this cannot be green here because we have... Sorry, this has to be green here because this is blue. We have a 2 by 2 that's all green, so it's blue here. What else do we have? Okay. So, we have to have a sum adding up to 12 here and a sum adding up to 1 here. Okay. This is 8. That eliminates 8 in the rest of the column. 9 eliminates 9 in the rest of the column here. This has to be greater than that, so it cannot be negative 8. No negative 7. Okay. How do we get sums here? So again, we could have 7, 9, 1, 2, 3, 4, 5. But 1 is not possible. Where is 1 in row 9? You can't have negative 1 here because that's going to be greater than whatever digit is there, or whatever value's there, if that's the case. Same with this. Same with these two. Same with this one here for this negative value. So 1 has to be one of these digits here. So this can no longer be 7 here. Because the next 5 digits would be at minimum negative 2, 3, 4, 5, 6, which is negative 20. We can't have 2 here. 2 digits here adding up as a positive value would be greater than 1. You could have 3. We're guaranteed 1 has to be one of those. Okay, so this cannot be 3, this has to be greater. This can't be 7, so this can't be 6 here. 6. Does 6 work? Yes, possibly. 6 and 9 could have 2, 3, 4, 5 here. That is possible. No, that's not possible. If this is 6, 6 and 9 is 15 at most. 2, 3, 4, 5 is the minimum here, which is negative 14, which does gives us 1, but then that would eliminate all possibilities for that cell. So that's not possible. So this can't even be 6. That means this can't be 5. Can we have a 4 here? Probably not, right? 4 and 3. Actually, that does work. 4 and 3, then you have negative 6. So that does work. Okay. The first 8 cells must be even. That means you have the same amount in a positive direction as you do in the negative direction. That's essentially like multiplying by 2. So you the sum of these digits must be something times 2, which is an even sum. And to add up to 45 for the digits, you have to have an odd sum. So this has to be an odd value. So you have 3, 5, and 7. Okay. 3 by itself is not going to work. These are all negative, really high negative values. So this has to be 4 here. That means this can't be 4 here. No more 4 in the rest of the column. No 4 there. 4 plus... This has to be then green. Because these are going to be too small for that to work. So this has to be 4 and then negative 6 and 7 plus positive 9. So we have, and that has to be the value. So then this is negative 5. No 5, 6, or 7 here. It's 8, 9 as a pair. 9 is here. 9 cannot be here. 8, 9 can't be here. 6 and 7 cannot be here. 9 can't be here. So this has to be 5 or 8 here. Interesting. Remaining digits of column 8 are 1, 2, 3, 5, 8. And we have 3 greens here, so this can't be green, so this must be blue. 9, the remaining digits of column 9 are 1 through 7. So 9 has to be either here or here. Well, if this is 9, is that going to work? None of these can be 5. That's interesting. If this is 9 here, does that work? Well, 3 and 8 add up to 11. But minus 9, it would give you 2 in value. So that's not going to work. What about 9 with that being 4? -9, -2, 4, and 8 does work. 12 minus 9 minus 2 is 1. So that does work. Okay, never mind. That's not as useful as I thought it was going to be. So 7 has to be one of these 3 digits here. Where are 8 and 9? In row 2. None of these can be 8 or 9 because 8 or 9 in the box, and only one of them can be here, so that means this must be the other 8 or 9 there. Interesting. We have 1 through 4 here, 1 through 4 here. This could be -8 or 9, or 1 through 4. Can we ever have 3 here? Yes, quite a bit. There's quite a few things that we could have with 3. If this were 8 here, this would have to be 9. I guess this could be green. If this is green, oh, that's interesting. If this is green, it has to be less than 4. So this would be green as 1, 2, or 3. So you're guaranteed a blue here has to be -8 or 9. Well, if that's the case... So say we had a -8 here, right? It's a blue 8 here. Because if it's green, has to be less than 4 at most. So obviously you could have 2 negatives here. But we're trying if this is green, right? If this is green, it cannot be 8 or 9. One of these would have to be a -8 or 9. So, if we only had 8, if we had 9 here, that means all the green cells would have to add up to 23, and all the blue cells would add up to 22. Is that possible? I guess so, right? You'd have 8 here as a negative. Then you have 5, 6. 8, 5, and 6 adds up to it's -19. Plus -1 and 2 would give you would give you negative 22 plus 23. So that would work. Okay. What else do we have? Okay. We have negative 10 here. So this cannot be 2, because if this were 2, you'd have negative 2 here, positive 1 there. You would subtract the negative 2, which would give us 2, and then you would subtract that value, which would be greater than 2, so it's not going but it's not going to be up to negative 10, right? So 2 plus negative, or 2 minus 9 is negative 7. So that's not going to work. So this can't be negative 2, which means this can't be negative 3. Interesting. Can we have 5 here? If this is 5, that's 8. That's what, 13? I guess it's possible. Huh. Remaining digits in row 3. We have no 5, 6, 8, or 9. So 1, 2, 3, 4, and 7. Interesting. Hmm. Okay. Oh, we have an 8, 9 pair. That's adding up to 17 already. This has to be 1 through 6. Yes. Okay, so we know we guaranteed have 2 digits here, adding up to 17. What are the possible remaining sums? We have negative 7, so that gives us the total of 10. If we don't have 5 or 6 here, we have negative 5 and 6 guaranteed. Okay, so if this is not 5 or 6, what is this at most? We have 8 and 9, 17, minus 7 is 10. Minus 5 and 6, which would be negative 11, so that's negative 1, plus 2, 3, and 4 at most, which is 9, which is way too small for this sum. And then this would be a negative also. So this has to have a 5 or 6 here. What happens if we have 5? What's the minimum value for 8 digits? Because this is just going to decrease it even more. So 17 minus 7 is 10. Plus 5 and 2 and 4. 5 and 2 and 4. Well, this is interesting. All the positive, so we know we count 17 cells here, either way. So it's either 17 that way or it's 17 this way. They must total 13 if you subtract out, if you get all the positives and subtract out all the blue cells. Okay. Is that helpful? I don't know. Um, okay, what happens if this is blue? We have 5 blues here, at least. Hmm. Hmm. I don't know if that's that helpful, going that route. We do know this is 5 or 6, though. Um, so we have 0 here, which could mean 20, 21, and 21, and 3. 20, no, yeah, 20 and 20, and 5. Or 19 and 19 and 7. Okay. That's not helpful right now. Okay. What else do we have? That's kind of all we have, though. It's just basically these two, this long one, and this one. We've already solved this. I guess we have this one too, but that's not really that helpful because this could be a lot of changes, right? Um, so can this be blue? Is kind of what we're asking, right? I guess if we have the other 8 and 9 being there, right? So then this would have to be greater than this. No, 1. This could be 1, 2, 3, 4, or 8. What's the largest this sum could be? 4, 7. We can't have 9 because that 4, 7, and 9 would add up to 20, but then the negatives would be 45 minus 20, which would be 25, and that doesn't add up to 1. So 4, 7, and 8. Does that work? No. 4, 7, and 8 at most. So 4, 7, and 8 adds up to 19. We would have to have negative. Well, we could have 3, 7, and 8. Hmm. So if this is negative, we can't have negative 8 and negative 9. So then this would. Oh, this is always 1 through 4 here. That's interesting. Right. Because. So if this is positive, it has to be less than 4. So this would be 1 through 3. If it's negative, it can't be negative 9 and negative 8. That would eliminate all possibilities for this cell there. And it can't be 5, 6, or 7 there. So that, and if this is negative 8, this would have to be negative 9. So this also has to be 1 through 4 no matter what. That's interesting. Um, huh. This, of course, could be 1, 2, 3, 4, 8, and 9. This can't be 1, so this can't be 2, no 3, no 4 there, because it must be constantly increasing. Um, hmm. Um, So if this is 8, we can't have a negative 9 here, right? You'd already have negative 9, negative 5, negative 6, which gives you negative 20. And this is at most 4, 7, and 8, adding up to 19, which would give us a negative 1 in value. So 9 would not be here. 9 would have to be here if that's the case. Then this would be 8. Why did I remove the 5? I don't know. Understand. That was weird. Maybe I went too far there. Yeah, I went too far. Yeah, okay. So this is 1 through 4. We have 1 through 4, 8 or 9 there. No 2, no 3, no 4 that way. So this can never be negative 9. If this is negative 9, that forces us to be 8. But again, this would be 4. Actually, hold up. If this is a green, though, that might work. So negative 9 there makes that 8. This could be 3, 4, and 7. Well, this would be negative 20. Obviously, 7 could not be here. 5 and 6 to get negative. Okay, so you can't have 2 here. That's already negative 22, but we don't have all 9 digits in this sum. So this can't be 2 or higher because you'd have either negative 22, and the problem is this can't add up to only 23, 22 at most. So you'd have to have 1 there, and you'd have to have this be 2. And then 3, 4, and 7, and that does work. Dang it. Okay. Well, never mind. That actually does work. Hmm. Right. 3, 4, 7, and 8. 3 and 7 add up to 10. 4 and 8 add up to 12. 22 minus 9, 1, 5, 6 is 21, which does add up to 20, which adds up to 1. So this could be 9 there. Can we ever have a negative 7 there? I don't think so, right? Yeah, if this were negative 7, that's negative 7, 5, 6 already. It's negative 18. Guaranteed, plus another negative 1 at least. Negative 19, and this would be 2, 3, 4, and 9 at most, which is 18. So yeah, this cannot be 7 here. So this is 1 through 4 also. So what happens if this is 9? That means every digit counts, and the difference is 12. We know, so x, which are the positive digits, sums, minus y, which are the negative digits, summed, would equal 12. X plus y is 45, because those are all the digits in the row. So x plus y is 45. X minus y is 12. So then you add them together, or you subtract them. You add them together. If you add them together, so x minus y would be 12. So if this is 9, x minus y would be 12 because they're all the digits. So all the positive digits subtracting out all the negative digits would have to equal 12. If you have x plus y, which are all the negative sum plus the positive sum, and you just basically take the absolute value of them, then they must add up to 45. So x plus y equals 45, x minus y equals 12. add those two sides together, you get 2x on one side plus y minus y, which is 0y. So it's 2x on one side plus 45 and 12 on the other side, which adds up to 57, which is not an even sum. So then you'd have x equal to a non-integer, which is not possible. So this cannot be 9. Therefore, this must be 8. That makes that 9 there. So that's not 8. This is 9. So that means, so we don't have 9 here. We have definitely a negative 8. That means these 4 cells. So it cannot be, this cannot be, so if we try to make this not green, we try to make that blue. The problem is these 3 digits by themselves have to add up to 23, but that's not possible because you have 4, 7, and 9 at most there. So therefore, this must be green here. Blue has to go out this way because there's no other way that this can orthogonally connect. And this must add up to 23 with 9 and 7. So 23 is not plus 9 and 7. This can't be 9. One of these is 8. This must be less than that, cannot be 4, so this can't be 1. Um, 7 and 9 add up to 23. Sorry, 16. And then to add up 23, 23 minus 16 is 7. That means this must be 3 and 4. So this has to be 3, which makes this 4. That makes this a 4, 7 pair, which eliminates 4 and 7 in the rest of the row. And box, no 4 here. No 4 here, no 3 here. No 3, 4 here, no 3, 4 here. No 3, 4 here. So now we have a 1, 2 pair in row 2, which eliminates 1, 2 of the rest of the row. Okay. So this is 8 digits. Interesting. 3's here, 4 eliminates 4 in the rest of the column. So this digit must be greater than that, so it can't be 5. 3 eliminates 3 in the rest of the column here. So we have 9, 3, 4, and 7. That adds up to 23. We have 1, 2, 5, 6, 8. Adding up to 22, which gives us a difference of 1. There's a difference of 12 between these digits here. So, it's 8 digits, though. So which one is this? 1 or 2? Oh, this has to be smaller than, well, it could be -1, -2, or -8. Okay. We have -3 here. So -3 and -7 is 10. -10. 17. We have 17 here. Plus 4 is 21. This can be 1, 5 up to 2, 6. So that's 6 to 8 is possible for the positive. So 21 plus 6. Let's do 8 first. 21 plus 8 is 29. 29 minus 12. So if this is 6, so okay, 6 and 2, this becomes -3, 5. And this would be 1. Does that work? We have 10, 29 minus 14 is 15. So the answer is no. That does not work. So this cannot be 2 and 6. Can it be 2 and 5 is kind of the question. If we have 2 and 5 there, 9, 4, 5, 8, 2. So 2 and 8. So 9, 4, and 5 is 18. Plus 10 is 28. 28 minus 9 minus 7 is 12. So that works. Can we ever have this be 2 is the question, right? So if this is 2 and that's 1. 5 there. So 1 and 9 is 10. Plus 4 and 5 is 9. 19 plus 8 is 27. Minus 7 is 20. Minus 9 is 11. So that doesn't work. What about 6 here? 6 here and 1 here means no 6 here. So 9 and 1 is 10. 4 and 6 is 10. 8 is 10. Or sorry, 8 is 8. 28 minus 15 is 13. So 2 cannot be here. Therefore, this must be 1 here, which makes this not 1. 1 eliminates 1 here, so that's 2, which makes that 3. That's 2. This is 1. No 1 remaining in this column. A 2 or 3 here. And again, 2 and 6 doesn't work. It's too large. So 29 minus 15 is 14. So then this has to be 2 and 5, which means this can't be 5. That's 3 and 6. 5 eliminates 5 in the rest of the column. That's interesting. 1 eliminates 1 here. So this must be a negative 1 there for row 9. And we have 2 and 8 is 10. 4, 5, and 9 is 18. 28 minus 16 is 12. So that does work. Okay. This adds up to 0 for the first 8 digits. If we have this be 7, 8, 5, and 7 is 20. That would force this to be 3 there. So it would have to be 21. So the other green in this column would be 1. And the rest would be all blue. That seems to work okay. If this were negative 7, that would make that 4. 4, 5, and 8 add up to 17. So no 4. This would have to be negative 9. That seems okay-ish. Remaining digits of column 2, we have 2, 4, 5, 7, 8. Okay. No 4 here. Two and 8 work, as this means it can't be 2. It can't be 1. So that forces this to be 1. So this is done. Okay, let's mark which ones are done. This is done. This is done. This is done. This is done. If this were negative 3, that would force this to be negative 2. Okay. We do have one interesting spot that we have to have a 1 in one of those two cells there because of the way that these thermos work. We have negative 3 here, negative 2 there. Can that work? That would mean no 3 here, no 3 here. That means this can't be negative 4. Four digits. It has to at least be four. 4 and 8 could work with 5 and 6. So that does seem to work okay. Dang it. I was hoping that would lead to a contradiction. Okay, what about... Does 3 work? 3 would have to be... Could be... That would force this to be 7. Well, that's interesting. That would force this to be -9. That would be force that to be 4, 7. That seems okay-ish. No 3 or 7 here. No 7 here. This can't be -4 because that would be smaller than it. This can't be -6, so it'd be -1 or 4. No 7 there. 3 plus 5 gives us 8, which would force this to be 7. But then that would be problematic because of the 7 in the row. So that doesn't work. 3 and 8 does not work because that's 11 again, which -9 at most gives us 2. So this cannot be 3 here. Well, okay, that's good to know. So no 3 here. Can we do 5 and 8 is kind of a question, right? So 5 and 8, that's 13, which means these 3 digits must give us -12. But we don't have 1 or 2 available because of these are negative and they must be smaller than this digit, which is a negative. Same with that one. And it can't be 2 or 3 because of 2 in the column. So 5 does not work anymore. 5 and 8, that makes this 13, which -12 would give us 1. But we don't have 2 available here anymore. So the minimum here of the subtraction is 3, 4, and 6, which is 13. 13 minus 13 is 0 at most, which means that doesn't work. So this has to be 4. That eliminates 4 in the rest of the row and box and column. So these 2 digits, can it be 4 and 5? No, because 4 and 5 would force this to be 6 and 3 at most. Or sorry, at least to subtract out. And 4 and 5 is 9 minus 9 means this is 0 as a sum at most, which is too small. So it must be 4 and 8. That eliminates 8 in the rest of the box and column and row. So these add up to 12, which means this adds up to 11 here. No 2, 9 available, no 3, 8 available, no 4, 7 available. It must be 5 and 6. So 5 and 6 here to add up to -11. That means this can't be 5 or 6, it's 7. That eliminates 7 here, it's 3. That means this has to be -2 to be greater than the -3. No more 7 here. 7 eliminates 7 here, so that's 4 and that's 7. Remaining digit in row 9 is a 9. 6 means this can't be, this has to be 1, which eliminates 1 in the rest of the box. This is 9 as the only place for it. No more, this is 2, 3, 5 as a triplet, which eliminates 2, 3, 5 in the rest of the box. So no 2, 3, 5, 6 there, it's 7. No 7 here. This must be a positive digit because -1 is the largest negative digit. 2 by 2 area, that's all green, so this is blue. This can, well, no. One of these is 5, which eliminates 5 in the rest of the column. Remaining digits of column 7 are 4, 7, 8. Okay, if this were 3, that would force this to be 2, which would eliminate all possibilities for this cell. So no 3 here, no 5 here, no 6 here, because of the way that that works. 2 eliminates 2 in the rest of the box. So again, we have 4 or 5 there. So this sum is going... Okay, so this is done. 5 digits must give us a negative 10. Okay. Um... hmm. 3 has to be one of these 2 digits. And we have 3, 4, 5, 6. This can't be 7 because of 7 in the row. So no 7 here, no 7 here, no 7 because of the thermometer. So whereas a 7 in box 7, it has to be there, which forces this to be 3. That eliminates 3 in the rest of the row. We know 6 has to be one of these 2 because there's no other place for it in box 7. Okay. Remaining digits of column 1. We have 2, 8, 4, and 6. That eliminates 4 in the rest of the box. So we have a guaranteed 4 here. Um, hmm. Okay. So we have 9 is going to have to be in a blue. So 1 is the only positive green we have left in column 4. So we have 1, 2, 4, 6, and 9 as possibilities. No 9 here. This could be in... So the 1 is the only green one left in column 4. Oh, we have to exit out somewhere. Or, well, okay, exit out that way. Never mind. Okay. Mm-hmm. Okay. So that's done, that's done, that's done. This is not quite done. That's done. This is done. Negative 10. That's probably the only one we can really use. Hmm. Remaining digits of the column. We have 3, 4, 6, 7, 8, 9. So no 7, 9 here, no 3 here, no 7 here. So 7's one of these 3. Guaranteed. 3 can't be here because of 3 in the box. One of these 2 is a 3. Okay. 9 cannot be here. So what do we have? We have subtracting out of 5, which means it's plus 5. We don't have 1 and 2 available. And 1 out of 3 or 6 is definitely not available. This can't be 9 either way. If this were 9, the problem is this digit would have to be greater than it, and this digit would have to be less than it. If it's 9 either way, it's either positive 9, which means this can't never be greater than it, or this is negative 9, which means that can never be smaller than it. So there's that. You could technically have these all be the same shade. That is potentially possible. Hmm. Hmm. Okay. -10. So the greens will outnumber the blues by 10. Or sorry, will outsum the blues by 10. Can we have only one green? The answer is no. 4 blues. I think it was the other way around that I was thinking of. Can we have 4 greens here? No. Um, because 4 greens would have to be at minimum. We can't have 4 blues either. Um, 4 greens would add up to a minimum of 3, 4, 6, and 8, which is 10 and plus 11, 21. And so -21 plus 5 is -16, which doesn't work. Otherwise, the sum would be like the subtraction would be even smaller than that. So that's not going to work. Same with 4 blues. So then it's a question of it has to be 2 and 3 in some order. Can we have 3 blues? 3 blues would give us -5 or 5, 4, and 3 at minimum. That's 12. And since they're negative values, you're subtracting them. That gives us a sum of 12. Minus 8 and 9 at most. So that's 17. 12 minus 17 is only going to be -5. So that's not going to work. So it has to be 2 blues and 3 greens. Guaranteed. The smallest blues would be 3 and 5. 8. To get to -10, the other 3 digits would have to be. Well, the thing is, we know 9 is always going to be in the set. Because 9 can't be in any of these digits here. So they're either going to be positive or negative. Can you have -5 and -9? Subtract those out. That's 14. The next 3 would be 6, 7, 8. So the answer there is no. Because 14 minus 21 at most is going to give you only -7, which doesn't get to -10. Okay. So 9 is guaranteed to be a green. What about -8? -5 minus -8. Then you subtract all that is 13. 13 minus, can you get negative? No, it'd be -679, which would be, so that would be 13 minus 22 at most, which is not -9. So 8 cannot be green if it's in one of these sets. Um, 5 and 3 doesn't work as the 2 blues. Because 5 and 3 is negative 8, or sorry, it's 8. Subtracting to get to negative 10 would be 18. So you'd have to subtract out 18. And you'd have to have a 9. Well, we don't have 4, 5, and 3, 6 available, or 2, 8, or 2, 7, or 1, 8 available. So that's not going to work. So 3 cannot be so the blue, the other blue in this column that is counted cannot be 3, 8, or 9. What about 4? If we had 4, 4 and 5 add up to 9. We definitely subtract out a 9 there. You could have it negative 3 and negative 6 with a negative, right? So 4 and 5 is 9. Subtract out 9, that's 0. And then you have 3 and 7 subtract out. So that could work. So 4 and 5 does work for the blue. 5 and 5 obviously doesn't work. 5 and 6, that's a good question. So 5 and 6 is negative. It would give you 11. That means the other 3 must subtract 21 to get you to negative 10. Okay, so in column 3, we know 9 has to be one of those two. That's interesting. So here, blue is negative. The blue here is 2, 4, 6, and 9. That will give us negative 21. The 1 is green, which gives us 1, 4, 5, 1, 5, 7, and 8, which adds up to 21 also. That gives us a sum of 20 of 0. This way. So again, 6, negative 6, and negative 5, or 5 and 6. Subtract down those out, and then subtracting it again gives us 11. So 21, so it would be 4, 8, and 9. Right? Because 11 minus 21 gives us 10. The only way you can get 10 is 4, 8, and 9. So if... still is possible. 9 cannot be here because of 9 in the row. So 6 works here too, as the blue. 7. What about 7? 7 and 5 gives us 12. 12 minus 12 minus 22 gives us negative 10. So 22 without 5 or 7 does not work for 3 digits. You have to either be 5, 8, 9 or 6, 7, 9. And we already have included the 5 and 7. So 7 cannot be the blue with it. So the blue has to either be 4 or 6. If you have 4, the remaining greens have to be 3, 7, and 9. And if you have 6, the remaining blues are... So, if you have 4 as the blue, you have 3, 7, 9 here. That forces this to be 6, which would make that 8. If you have 5 and 6 as the blue, that's 11, which would leave 4, 8, and 9 as the remaining green, which would mean this is 7 and this would be, so this is 7 or 8. Ugh. Not helpful. Okay. We know we have a guaranteed 1 here. We have a guaranteed 1 here. Hmm. um, hmm. It's kind of rough actually for this portion. Um, Anything else? I think it's just this, right? Yeah. So we know 4, 6 is the other blue here. We know the other greens have to be either 3, 7, 9 or 4, 8, 9. Hmm. Remaining digits of column. Hmm. Remaining digits of column 5. 1, 2, 3, 5, 6, 8. Okay. No 3s here or 5s here because of 5s and 3s in the boxes. No 1 here because of 1 in the row. Hmm. So 5 has to be one of these 3. Oh, that's interesting. Is that really? I don't know. Maybe not. Um, Remaining digits of column 3. We have 1, 3, 5, 6, 8, and 9. Obviously, no 9 there because of 9 in the row. No 6 in either of these because 6 is one of these two. Hmm. Do we have anything else? Not particularly. Uh, if this were 1, all of these would be green. Sorry, blue. Um, if this were 2, all of these would have to be blue. Obviously, if it's 8, that's fine. We know 7 is here. Hmm. 2 and 5 are both less than 7. So 9 has to be one of these two. 9 could be one of these 3. That's not that helpful right now. Uh, so if this is 1, that means all of these are blue. We have a diagonal here that's all blue. A diagonal here, it's all blue. So then these have to be opposite colors. So we'll make that orange with yellow. That makes that orange and that yellow. Hmm. Hmm. Oh. Okay, hold up. So if this is 1 or 2, actually if this is 1, 2, or 3, these must be all blue. Um, so if that's the case, we have a diagonal here that's blue, so this cannot be green because this is already green. Therefore, this is blue. 2 by 2 area, that's all blue, so that's green. 2 by this can't be diagonal of all green, so that's blue. 2 by 2 area, that's all blue, so this is green. 2 by 2 area, that's all green. This can't be green, it's blue. And 2 by 2 area, this is diagonal. So this can't be green, it's blue, and we have a contradiction. So we know then this cannot be blue. If this were blue, then that leads to that scenario. So this has to be green. Can this be blue and blue here? Possibly? No, I think it's a, well, not necessarily. Obviously, this can't be blue in that scenario. So this is, first of all, this is definitely green. So that's helpful. Which means this is green. So this must be greater than that. So no 1, 2, or 3. This can't be 8 anymore. So this must be greater than that digit there. We don't have... Okay, so... So if this is blue and blue, we cannot have blue here because that... Or we can't have green here because that would lead to this being blue. Well, actually, can we? Let's see. Green forces this to be blue, which means this can't be blue. It must be green. And then we have the deadly pattern. Right. So then that forces this to be blue, which means we have 3 blues here. So this must be green. You can't have diagonal that's all blue. That's all green. The opposite. So this must be blue. Diagonal blue here. So that must be blue there. So that seems okay-ish. This is the last green, so this must be all blue here. Green has to orthogonally connect, so that's fine. Diagonal, that's all green, so this must be green there. So far that looks okay. We have 3 green, so this must be blue. 3 blue there, so that makes that green. Diagonal, that's green, so that makes that green. 3 blue green here, so that must be blue. Blue has to orthogonally connect, so that's blue there. Green has to orthogonally connect, and that works, actually. Ooh. Okay. Then let's try the other way. So let's make this green here. So if this is green, that means 3 greens here. This must be blue. Let's make it all green. That makes that green there. 2 by 2, that's all green. So this can't be green, it's blue. We have 1 green here, so the rest must be blue. That is 1. So that does kind of work. 2 by 2, that's all green. So that's blue, that's blue. 2 by 2, that's all blue. So this cannot be blue, it's green. And the blue is not orthogonally connected as a region because of that. So we know this can't be green. So this is blue here. So this is blue guaranteed here. Can we have green here still? 2 by 2 diagonal here. This is 2 by 2, that's all green, so this is blue. 2 by 2, that's all blue, so this is green. 2 by 2, that's all green, so this is blue. 2 by 2, that's all blue, so this is green. We have the fated diagonal of both colors being the same, so that's not going to work. Therefore, this can't be green, so this must be blue. Okay. Now we know that. This is blue, blue. Again, diagonal, it's all blue. This can't be blue, green, it's blue. 3 by 2 by 2 area, that's all blue, so that makes that green. Diagonal, it's all green. That makes that green there. Blue has to orthogonally connect, so it goes out that way. This is less than that, so it cannot be 1. Can that be blue? I don't know. So this is less than that, so negative whatever. That's greater than that, so that's whatever. This can't be 7. That forces this to be 8. And that would eliminate all possibilities for that cell. I believe that's okay. One of these is blue, one of these is green. We're not sure which. Green, green, that's blue. The blue has to orthogonally connect to the other blues. I guess it could just do that, potentially. These are opposites. We'll make this pink, and we'll make that yellow. These are opposites, so that must be pink. These have to be opposites because we have 2 greens here, so that makes that yellow. We have 1 blue and 1 green here. So whichever one this is yellow. That makes that pink. Because we need to add up to -10. If this is green, then that's not going to work. Because if this is green, blue has to orthogonally connect out, but these are guaranteed to be different sets. Because to get to the -10, we need 2 blues here and 3 greens. So this cannot be green. This has to be blue. Okay. We have 1 of each there. This cannot be 2 of the same color. Because if they're 2 greens, that's 2 by 2 area, that's all green. If they're 2 pinks, if they're 2 blues, I should say, then that blocks this from orthogonally connecting. So therefore, this is not pink, it has to be yellow. We have a diagonal here that's the same color. So these can't be the same color, which means pink has to be blue. So pink is blue, yellow is green. This is the last green there, so that's 1, which means the rest of the column is all blue. And we have to orthogonally connect the greens. So that gives us that. So no 1 here. 1 then has to be here. That eliminates 1 in the rest of the box. And 1 in the rest of the column. So where's the 1 in column 3? It has to be here. That leaves this as a 9. This can't be 6. 6 is one of those. 2 eliminates 2 here. Oh, wait. How did I miss that? Anyways, this is 8. That's 2. No 2 here. 8 eliminates 8 there anyways. No 8 here because of the 4, 6, 8 triplet. That eliminates 2, 5, and 7 in the rest of the column and box. This can't be 5 or 8. It's 3. 8 eliminates 8 here, so it's 6, 5. That makes that 4. No 4 or 5 here. That makes that 8. No 8 here. 5 eliminates 5 here. It's a 2, 3 pair. That eliminates 2 and 3 in the rest of the row. So no 2. 6 eliminates 6 here, so it's 4, which makes this. So this is -4 and 5. No 4 or 6 here. It's 2, which makes that 5. No more 4 allowed here. 2 eliminates 2 here. This digit is smaller than that, so that's fine. Again, this is 4. 3 eliminates 3 in the rest of the row. We have 4 and 5 here. And that was minus 3, 7, and 9. So this can't be... This has to be then 3, 7, and 7 must be there. That's 9, which means this can't be 7. That's 8. This can't be 3. It's 6, which makes that 3. 3 eliminates 3 in the rest of the row also. Cannot be here. 8 eliminates 8 in the rest of the row. So we have, again, -5, -4. Subtracting those is 9 minus 3, 7, and 9, which is 19, which gives us -10. So this is done. So this is done, and that's done. 9 eliminates 9 here. That's 6, which makes that 8. That eliminates 8 in the rest of the box. And 6 here. 9 eliminates 9 here, so it's 4, which makes that 9. 4 eliminates 4 here. 7 eliminates 7 here, so it's 8, which means this can't be 8 here. That eliminates 4 and 8 in the rest of the row, so no 4 and 8 here. It's 6, which makes that 5. No 5 or 7 there, it's 2. That means this can't be 2, 5, or 6. It's 3. This can't be 2 or 3. It's 1, which makes that 2. 2 eliminates 2 here, so it's 3 and 2. No more 2 here. 2 and 5 eliminate 2 and 5 here, so it's 2, 6. 6 and 5 eliminates 6 and 5 there. It's 2. No 2 here. 6 eliminates 6 here, so it's 4, which makes this 8. 4 eliminates 4 here, so it's 7 and 4. 7 eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so it's 6 and 5. And that's the solution. Yeah, just a lot of adding and subtracting, which, yeah. It's fine. Yeah, the execution was hard here. The logic wasn't very hard at all. But the execution was the hard part here. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.